Okay, let's start with page 4 and this part. Calculation of net force by using net force equals to MA. Okay, so case 1 is horizontal force and vertical force. Given that a book with mass 1.5 kg is placed at rest. Okay, at rest actually means here U equals to 0, initial velocity 0, V final velocity 0, and A acceleration 0, right? So now, may I know what is R, the name of R? Yes, thank you, Eric. Yeah, it's normal reaction. So normally normal reaction, we don't write force, but actually it is force. Anyone can explain what's the meaning of normal reaction force or normal reaction? Yeah, something placed on the solid, and this solid give back supporting force. Actually, it is supporting force lah. Okay, so now the weight. Calculate the normal reaction force from the table. The weight. The weight actually is a force too. It's a force. Both are force. So how to get weight? Since mass is 1.5, weight would be 1.5 times 9.81. Right? So R equals to question mark. R is a normal reaction. In this case, acceleration equals to 0. So we can write in this way. Always write when there is force and mass, we always use net force equals to MA. Okay, so net force. Anyone can explain actually what is the meaning of net? Beside Eric, anyone can tell? Total. Total can, but normally total we would use sum also. Normally this one we will use the math signs as plus. But net actually means minus. Okay, so it's after you tolak, then what's left? What's left? Okay, for example, a bag 100 ringgit. A bag 100 ringgit. Okay, maybe it's LU bag. Okay, but after net price is 60 ringgit. So net actually means after you minus 40, 100 minus 40, net you left 60. Okay, yes, actually when we explain, yes, when we explain we say net is total or sum. But in this case, we always think about plus. And actually net means whatever left. That's why net force here actually is R minus W equals to MA. R is normal reaction, W is weight. Both of them are forces. So here, W equals to 1.5 times 9.81. 1.5 times 9.81, you will get 14.715. Okay, so 14.715 equals to M8. A is 0. So anything times 0 becomes 0. Okay, so can you see actually we are doing left hand side, just we collect, we kumpul all of the forces, and right hand side, right hand side we use mass times acceleration. Okay, so mass acceleration right hand side, left hand side is force. So now if we want to find R, so we move this one, then it will become positive 14.715. Now answer R equals to 14.715. Can I get marks? For final answer, can I get marks? Yeah, you must add the unit Newton because normal reaction is a force, so Newton. Alright, so now another way is you can substitute everything first. Then you make it as algebraic formula. You arrange everything to the left right hand side already, then only you substitute. M is 1.5, A is 0 plus 14.715. So still become 14.715 Newton. Up to you, but I like to substitute in original formula. Okay? Okay, so now this one. Given that the frictional force is 500 Newton, so since this is the diagram, we can write our info here. So 500 Newton. Normally frictional force we write Fr. Frictional force means the drag between two solid objects. Means between tire and the ground. Okay, then they say what? The mass of the trailer is 2,000 grams. So mass of the trailer 2,000 grams means weight of the trailer would be mg. Okay, mg means 2,000 times 9.81. Okay, and the acceleration of the truck is 20 meters per second. So we can draw our direction here. Acceleration equals to 20 meters per second per second. So this is truck. So since truck and the trailer, okay, connects together. So they want the pulling force on the trailer. Okay, pulling force actually is horizontal. So frictional force also horizontal. So actually we just count these two only. They didn't ask about normal reaction and trailer. So we just ignore them. Okay, horizontal force only. When they are in parallel form, frictional force like this, pulling force like this, we only can sum them up in parallel form. Okay, so now what is pull? Pull actually is a force. So since we got weight, we got force, same thing we use And we got A. So same thing, we use net force equals to MA lah. So now M is 2000. A they give already 20. May I know how to write the force on the left hand side? Anyone can tell? Which force is bigger? Pulling, actually we are looking on these two forces only. Pulling force and frictional force. Okay. So which one is bigger? Of course, pulling force. Because pulling force makes motion to the right. So we say pulling force minus friction equals to MA. So let's remember net force means actually here got two forces. Net force means two forces minus each other. Understand? Two forces minus each other. So pull we don't know. Pull we don't know. So we say pull force equals to don't worry. Pull force equals to 40,000. Sorry, minus friction. Friction is 500 equals to 40,000. So pulling force actually equals to 40,000 plus 500. So the pull force equals to 40,500. What's the unit here? Someone, can you please type? What's the unit here? Yeah, Newton. Understand? Newton. Because pull is a force. Okay, so actually here give four forces. Normal reaction, weight, frictional force, pulling force. But since they are asking pulling force, this one only. So we just look at another one parallel to pulling force, which is frictional force. So actually in this case, we just use 3 and 4 only. They parallel. Okay, even though direction different, but they are parallel. Okay. Okay, so next, an apple is hanging in the air at rest. Given that the mass of the apple is 0.3 kg. So we say mass is 0.3 kg. Calculate the tension of the spring. Tension of the spring equals to how much? So first of all, when you see an apple, you look at the free body diagram. Means you draw the line to shows the direction of force. So here, direction of force shows free body diagram. Anyone can tell me what are the forces showing here? Okay, Angel, thank you. Weight, yeah. So this is weight. Weight equals to mg. Weight is a force, So what is T? Sorry, what is this force? What force is it? Air resistance. Thank you. Thank you. But not air resistance. Actually, here got a string. So, yay, thank you, MF, thank you, Angel. So, actually, this is a tension of the string. Since it's hanging, it's a string, means it's a solid thing. At rest. Anyone can tell me what's the meaning of at rest? Acceleration equals to. Thank you, Wasim. Thank you, Manfred. Acceleration equals to 0 means what? Means initial velocity 0, final velocity 0. So acceleration equals to what? V minus U over T. So 0 minus 0 over whatever time it will be 0. Right? At rest. So always keep an eye on at rest or stationary. Okay, so actually we get A equals to 0. Savendra, what? Savendra, you send wrong message. You are not focusing. You are not focusing. Okay. And when too many people, I think I need to on the participant only can chat with host, right? Okay, so now, what is the formula we use? So since got force, got mass, got A, yes, you only have one formula to use. Net force equals to MA. So M we already know 0.3. A, since it's at rest, means A0. Okay, now what is net force? Anyone can give me an idea? For me, net is minus. Two forces minus each other. Sorry. The big one minus the large one. Anyone can tell what should I write here? Okay, thank you, Wasim. Yeah, we can say T minus W. Since it's not moving, we normally use up force minus the down force if it is not moving. Okay, so we can use T, we don't know, but weight we know. Weight equals to 0.3 times 9.81, and we will get 2.943 Newton. 2.943 equals to 0. Okay. Okay. So T will T will equals to positive 2.943 Newton. Now get it? We always use net force equals to MA. Net force means one force minus another. Alright, now again, this is a free fall feather. Given that the mass of the feather is 0.02 kg and the acceleration of the feather falling down is 1 meter per second. Oh, sorry. This one wrong already. Meter per second per second. Calculate the air resistance of the feather, right? So anyone can label the free body diagram. Free body diagram. Actually, they draw arrow for you already. Can you fill up the name here? Thank you, Manfei. Yes, going down always is weight equals to mg. Up here is, thank you, Sarvendra. Yeah, but Sarvendra, you only give one force. We need a pair of forces, means we need two forces. Yes, thank you, Aiden. Yeah, going up now, yes, this is air resistance. Okay, so now, if there is acceleration going down, falling down with acceleration, let's draw an arrow down. Acceleration equals to 1 meter per second, understand? So now, let's use a formula. Got force, got acceleration. Yes, only one. The net force equals to ma. Okay, now mass is 0.02 kg. So we put here 0.02 kg times 9.81. And we will get 0.1962 meters. Okay, so here we substitute mass is 0.02, acceleration going down 1. May I know what should I write here? If air resistance, we use the symbol R. Okay, so R minus W. So actually, so sorry. I say up minus down. Just now, yes, up minus down. But with the condition, acceleration is 0. Means either at rest or either constant velocity. Okay, up minus down. But if there is acceleration, we always follow the acceleration, the direction of acceleration. So means down actually now, the down one actually is the bigger one, the up one is the smaller one. So actually we should do this. We follow the direction of acceleration, should be weight minus the resistance equals to 0.02 times 1. Get it? Because you move downwards. Because the feather moved downwards. So now the down one is bigger than the up one. So we say W bigger than R resistance. Yes, so now we W minus R. So the weight is 0.1962 minus air resistance equals to 0.02. So now next, what is your R? Can you press calculator and tell me? Because here always got the common mistake. Zero point 0.1762. Okay. Okay, so R equals to 0.1762, 0.1762. What else? Okay, okay, so if you get negative, I believe you are doing this. You are doing this. R equals to 0.02 minus 0.1962. Okay, there are, I believe some of you may, okay, now, I believe you have, um, okay, so which one is correct? A or B? Sorry. Um, which one is correct? Please vote. Okay, Savendra, Aiden. Please vote. The rest, oh, Manfei neither can show me your, can show me negative R. Oh, okay. Can, like that, can. So negative R equals to 0.02 minus 0.1962. Then negative R equals to negative 0.1762. Negative cancel. This one, okay. So 0.1762. Can. So actually, A cannot. A cannot. A cannot. Yeah, A cannot. Because why? Because actually when you move this to another side, it's minus, correct? But A forgot to bring the negative down, right? So your answer will be in negative. So A wrong already because forgot to leave negative R. But if you do this, you pull the negative R down here. Yeah, it's okay. Yeah, very good. Okay. So remember Newton. Okay, a bird is flying in the air with constant velocity. Anyone can explain what is constant velocity? Means acceleration equals to 0. Yeah, no acceleration means initial velocity is, let's say, 10 meter per second. So V also will be 10 meter per second. Means no acceleration. Means acceleration 0. Then now, calculate the drag of the bird if the thrust force is 20 Newton. Anyone can tell me how to draw the free body diagram? Label two forces enough. Or anyone can annotate. Okay, thank you very much. I did my mistake. Yes. Yeah, right. Air resistance is very good. Okay, so this is air resistance. So in this case, the drag is air resistance. Okay. Gravitation. Okay. Gravitational force acts on the mass. Actually, what is this? Anyone can translate. Yeah, actually it is weight. So weight equals to mg. We don't use acceleration force on an object which has mass. We just say it is weight. Okay? Now, do you think we can solve the problem by using drag and weight? No. Yeah, thank you, Angel. No. Because they are not parallel. So if we want to find drag means the air resistance, we need to find another force which is parallel to drag. So we need to find this. Weight cannot help in drag because weight actually pair with a lift force. Lift is a force, lift force, right? So may I know what is the name of in front? This is front, this is back. Yeah, thank you, truss. Thank you, yes, so yes, this is a truss. So truss actually is a force. Okay, weight is gravitational force act on that object. Weight is a force. Drag is a force. Everything here is a force. Okay, so now they say if the thrust force is 20, so if we got diagram, we label everything on the diagram. So thrust force 20 Newton. Now, yes, we can do because drag to the right, thrust to the left, alright? So when they are parallel, yes, we can do. So they always use F net equals to MA. So M, they don't give M, they don't give and maybe we leave it first. How about A? They give A or no? They give A or no? Yeah, very good. So actually constant velocity A is 0. So anything, they don't give, never mind. Anything times 0 becomes 0. So what is the net force? Don't worry about it. What is the net force here? 20 Newton. How? Thank you, Angel. Thank you, Sabendra. Yes, net force, you need to, actually you need to minus two forces and call net force. Thank you, Kim Manje. Okay, so actually it's moving in front, right? So we say it's thrust force moving here. Even though acceleration 0, but still moving here. So we use thrust force minus drag or the air resistance, okay, equals to 0. Thrust, we know, thrust 20 minus R equals to 0. So we'll get negative R equals to negative 20. R equals to 20. Okay. Can I get marks? Yeah, Newton, thank you very much. Air resistance, drag is a force, right? They are forces, right? So actually here we can get a conclusion about what? If acceleration equals to 0, front minus back equals to 0. Front minus back equals to 0. Okay, so we also can say the force on the left hand side automatically equals to the force on the right hand side, or the force in front equals to the force at the back. Normally this question only 2 marks. Final 1 mark. Substitution 1 mark. Means you need to substitute the number. Okay. Either this or this 1 mark. 2 marks only. But you don't look down to 2 marks. 2 marks can makes you from maybe B to B plus, A minus to A already. So the trouble things is, can you recognize what force are them? Do you minus them? Okay, so now next. Now question F, G, H are related to each other. F, G, H related to each other, right? So now, given that a car is stationary, what's the meaning? A car is a pencil, is it? A car is a ruler, is it? Thank you, Bethany. Now you all can give me answer directly to everyone. Yeah, thank you. Yeah, thank you, Sabendra. So actually, Stationary have the same meaning as address. Okay. Stationary, not only books, pen, ruler, or anything, but the case here actually saying it's address. The stationary means address. Means acceleration equals to 0. Means initial velocity is 0, final velocity is 0. Given the mass of the car is 500 grams, that's right, gram per kg. Find the normal reaction of the car. Now, can you please label a pair of forces here? They show you direction already. Yeah, actually it's weight. And what is on the top? Upwards. Frictional force and weight. Okay, when a car is stationary, yeah, got frictional force lah, but it's not moving, so normally we not moving, we don't count the force in front and force at the back because not contacting well. Okay, the battery. Okay. So no more force in front and at the back lah. Yeah, thank you. It's normal reaction or reaction force lah. So some books they write M, but our books write R. So actually here is reaction force. Can say normal reaction, can say reaction. Okay. So let's say this is R, this is W. So now find a normal reaction. So same thing, let's start with net force equals to MA. Okay, net force equals to MA. So net force actually is, since it's stationary, no acceleration, so we can use up the upper force, up force minus the down force. Bibi? Huh? Who call me Bibi? Hey. Thanks for calling me Bibi. Wow, long time never. Long time already. No one call me Bibi. Okay. Bibi is like oh dear, oh baby, or something like that. I think my mom also long time never called me Bibi. Once my infant time finished over and I was a child, my mom never called me as baby anymore. Okay lah, never mind. They ignore. Right, so now actually this one, the net force will be, the up force is reaction, normal reaction minus the weight equals to mass 500 kg times acceleration 0 because stationary. Just not in the school, not in the school. If outside in shopping center you see me, I want to call me Bibi. I'll feel goosebumps lah. Yeah. But not in the school. Thank you. But anyway, in the school, I still your fierce teacher. Like outside of school after you graduate, okay. Okay, so now this is 0. Okay, so normal reaction, we don't know. And we want to find normal reaction. Put a question mark here. Then weight equals to mg. So mg equals to 500 times 9.81. So we will get 4905 Newton. So 4905. I encourage you not to write Newton in the substitution. Yes, wait. Actually, when they give you mass, you can substitute mass times gravitational acceleration. It will become your weight. So if you get mass, you automatically will get weight. So we say R equals to 4905 Newton. Yes, when acceleration equals to 0, up force equals to down force. Of course you can save one steps here. Actually, last time I wasted that. Wasted. You can save the steps for this lah. But why I purposely add one more steps here? Actually, I can directly move. I will say left hand side. The force on the left hand side equals to the force on the right hand side. But I purposely add these steps to remind you or remind myself. Net force actually is when the force in parallel, one force minus another. Okay, once you accept the setting, okay, net force one force minus another. You know, left equals to right, up equals to down. You want to skip this step, okay lah. But anyway, I still will use it. It's not like maths, you know. Last time I treat physics like maths. I also feel why we need to write one more steps. No need lah. R equals to this enough. Then after a long time I forgot. Net force actually got two forces. One force minus another. Okay, so now please don't skip this step yet. Don't. Just one more step, alright? This step can remind you net force is one force minus another. Okay. Last time I gave out, I know everything. I skip the step. And after that only I find out why my teacher write that. Actually is one force minus another. So actually your formula give you this. Your formula give you, where is it? It's in Form 4. So actually Form 4 Chapter 2 we learn Force and Motion 1. Form 5 Chapter 1 we learn Force and Motion 2. So actually they already give F equals to MA in Form 4. So they don't give you any more in Form 5. Okay, F equals to MA lah. But They give you F only. So many people will think F. Very good. F. So you substitute one F only goes to data. So one F. So, but remember, F actually means net force. So I prefer you write in this way. Net force means one force minus another. Okay, not only one force, two forces. Okay, so yeah, so last time for some time, for some, I cannot solve this problem because I always think that force is one force only. Actually, it's no, it's one force minus another. Okay, now a car is moving with constant velocity. Anyone can translate constant velocity? Thank you, Brittany. Thank you, Savendra. Thank you, Eric. Thank you, Josephine. Thank you, Manji. Thank you, Manfred. Yeah. Constant velocity means uniform velocity. But I want you to translate in maths, right? So maths means acceleration 0. Why? Because uniform initial velocity is 10. Final velocity is 10. 10 minus 10, 0. So acceleration 0 means actually we can get one conclusion already. Net force equals to ma. A equals to 0 means something minus one force minus another equals to 0 means one force equals to another force. One force minus another equals to 0. So one force, this one you move here, equals to another force. Now continue. Find the fractional force. So Fr equals to question mark. They want to find Fr. So we always find the unknown with question mark. Of the car, if the thrust force is 1000 Newton. So the thrust force is 1000 Newton. And the mass is 500 kg, the same as just now. Same as just now. So, and the velocity is constant. So, since they want fractional force, means we only see the two forces in parallel, even though their direction opposite. But these two parallel, we don't care about the rest. For this case. So now, can you please tell me what force minus what force? Is it Fr minus thrust A or B, thrust minus Fr? Which one? Thank you, Bethany. Thank you, Eric. Thank you, Elisha. Thank you, Savendra. Yeah, correct. The rest? Thrust. Yes, actually it's thrust minus Fr. Understand? It's thrust minus Fr. Look at the direction of motion. We always use the direction in motion minus the back one. Okay, so see, don't look at left right. Look at the front and back. Now, for example, the front for this bird is left hand side. So actually it's front minus back. So in this case, actually this is front, this is back. So we use front minus back. Yeah, so answer is B. Okay. So now it will be trust equals to fractional force. So trust equals to, sorry, since we want fractional force. So frictional force equals to trust 1000 Newton. Okay. So always start with this formula. My maths consider okay. So last time I feel why my physics teacher do so long? No need lah. Front equals to back. Then after that, you know lah, I confuse. my maths okay. Not normally A lah. Okay. But after I study for a long time, till into university, then I understand why we need to write longer bit because concept is different. Okay, now the car is moving with acceleration. Find the thrust force of the car. Okay, so thrust force of the car equals to question mark. If given the acceleration is 5. Okay, so now acceleration is 5. So this is front and this is back. So actually they want thrust means we just look at friction. Up, down, we ignore. Normally ignore means they balance lah. They won't go up, they won't go down. Okay, so same thing lah. Net force equals to MA. Okay, M just now we know is 500 kg. 500 kg. A is 5. Wow, now A got some number already. So what is net force? Net force will be thrust force minus, what force is it? Minus frictional force. Yeah, frictional force. Yes, you need to fill up the name of the force yourself. See, they purposely don't remind you got frictional force in the previous question. See, they don't even tell you there is frictional force. No, so you need to look back yourself. Actually, it's frictional force. That's why I say this question is exists in I think SPM 2016. Yeah, so they don't remind you there is frictional force, but there is. Okay, so frictional force from here 1000 Newton. 1000 Newton. Teacher, usually math supposed to be in kg or gram. SI unit kg. But gram too small, so they use kg. Very good. Any question? Ask. Okay, so thrust minus 1000 equals to 22,500. So the thrust equals to 2,500 plus 1,000, 3,500 kg. Correct? Normally when I ask correct, means something wrong somewhere. Anyone can tell me my mistake. Yay, thank you, Angel, Josephia, Arisa, Vendra. Yeah. So when you write, you need always check back what's on your left-hand side. Trust is a false, so it's new. Just one more step, 1 second only. Once you write, you need look back to your left-hand side. And are they paired? And that's it. Okay, many students does not do the last check. I am wrong with it. That's why left-hand side, don't skip. Make your subject on the left so that you can check your unit. Why I say so? Because last year when I marked your answer, many students forgot to write unit or write unit wrongly. You count everything so many effort, finally wrong. Ai, kesian. Not only you, Form 5 also, the Form 5 trial when I mark, still got some of the students write wrong unit, then the marks gone. Okay, so now why the frictional force is 1000 and actually is maximum lah. So 1000 means the force in between the tire and the root, if their surface never change, then the frictional force will not change. Actually, last time from 2, we learned the frictional force, but they take out the experiment. So now you just remember that before this is 1000. Okay, now coconut. Coconut with mass 2 kg is falling with the acceleration 9 meter per second per second. Okay, this is answer. Sketch the free body diagram. Can you please sketch now? Sketch the free body diagram on coconut. Okay, now I show you the answer. You can either draw on the coconut up and down, or you want to draw beside. You don't want to draw on top on coconut. You want to draw beside also can. Okay, so up actually is, okay, down. Down actually is weight. Up number is what? Is it tension or air resistance or lifting? What is the name of the force? Thank you, Angel. Yeah, it's air resistance. See, there are air resistance. Normally we don't write R, sorry. We write FR. Because FR could be air resistance, could be friction. Normally R we write for normal reaction. Okay, so now calculate the resultant force acting on the coconut. So we can, so number 1 we already draw, sketch. So number 2, calculate the resultant force equals to MA. Okay, so actually resultant force can be found from net force or can be found from the MA. Since we got M, oh, one more, please write an arrow here. Acceleration 9. We always add one arrow for ourselves to check where is the motion. So since we got M, we got A. No need left hand side, we can get 2 times 9 and we'll get net force is 18 Newton lah. Okay, so now state the direction of resultant force. Of course, downwards. So what is the magnitude of air resistance acting on the component given that gravitational acceleration 981? So actually, so am I correct? Am I wrong? What's wrong? What's wrong, baby? Yeah, I never use 9.81, but seems okay. Seems okay. No, okay, man. Okay, what? No lah, actually wrong. Wrong. We must start again. We must start again in net force equals to MA. Even though up you use already, down use one more time. Same formula. So F equals to MA actually you get 18, it's correct. Okay, or maybe you substitute one more time. 2 times 9, 18. But the question here, what is net force? So actually we want what? We want air resistance. So air resistance equals to question mark. But air resistance related to weight. Weight equals to mg. So it's right here. We use the motion, the direction, the force. We use the force in the direction of motion going down minus the direction opposed to motion. Of course, this one we also can say is a drag, but I prefer you all identify what's the drag. Is it air resistance or friction or anything else? Actually, here is downward force is weight minus the air resistance. Do we know weight? Yes, mg. mg means 2 kg times 9.81 minus frictional force. So frictional force equals to 1.62 Newton. Answer is here. Okay, now you understand why just now, because just now you didn't write net force. Net force means one force minus another. So you just write one force, wrong one. So net force means one force minus another. Which one minus which one? If here got motion down, so you use a downward force minus the upward force. Can you get it? That's why always start with net force equals to MA. Don't write this, write net force to remind you there are two forces. Remind yourself there are two forces. Right, so now next. Now this is SPM 2016. This one shows a car 900 kg, mass 900 kg, accelerating on the road. Oh, sorry, one more. Net force you can find from M times A or one force minus another, alright? So see, this one is one force minus another, or MA lah. Okay, so now what is the acceleration of the car? So actually this is front is more than back. So acceleration going this way, question mark. So what to write from starting point? What's the formula related mass, force, acceleration? Thank you, Savendra. Thank you, Bethany. Oh, okay. I'm asking what. So now we got all of the info already. Actually, this is frictional force. This is a thrust force. What is the formula? Yes, Savendra, very good. Formula, please write net force equals to MA. A 900, A, M 900, A don't know, leave it as A. Net force should be front minus back, so it's thrust minus friction. So we will get 2000 equals to 908. So A equals to 2.22222222. Yay, answer is A. I prefer you all use 4 decimal places. Meter per second, okay? Before 2022 SPM, before 2022, yeah, 2022 SPM, yes, 2 decimal place is enough. After 2022, actually they want 3 decimal places, especially for chapter 3, form 4 chapter 3, the gravity was too many decimal. They prefer at least 3. So I think to play safe, why not we just put 4 decimal places? The safest one. You can write more than 4. Can, no problem. Can. And write 8 also can, but at least 4. Yes, 4, okay. Actually, more decimal better. Especially when your sine, cos, tangent, your trigonometry, since you learned in maths already, I believe you all will find out the sine, cos, tangent, the answer, if you don't use more decimal places, the answer seems totally different. So we use 4, play safe. Right now, diagram 6 shows a cyclist on the route. Okay, mass of the cyclist 60, mass of the bicycle 8. What is the total downward force acting on the route? Answer? Net force equals of MA. 10, but no need, they just want downward force. So actually here got the mass of cyclists means the weight of cyclists. And the weight of bicycle, So we can say weight, total weight, downwards means weight of cyclist plus weight of bicycle. So so it's mg plus mg CP. So m is 60 times 9.81 plus 60 times 9.81 plus 8 times 9.81. So when you factorize it out, 60 plus 8. Okay, so 68 times 9.81, 667.08 Newton. Of course, you don't want factorize also, it doesn't matter. Just times plus times, you also give the same thing. Yeah, 667.08, correct. So downward force. Okay. Downward force means the weight plus together log. Right, so now, like, which situation shows forces are in equilibrium? Anyone can help me translate into math form? Yes, thank you, Bethany. Yes, net force equals to 0. Why net force equals to 0? Because mass cannot be 0. Impossible to become 0. So it means acceleration is 0. Acceleration is 0 means 2 cases. One is the object at rest, or we say stationary. Another one is the object has constant velocity or speed. Yes, so let's check one by one. They want net force 0, acceleration 0. Okay, object at rest means u equals to 0, v equals to 0. Constant velocity means, let's say u equals to 10, v also equals to 10. Means we got velocity, just velocity never change. So now a car speeding up on a highway. Speeding up means got acceleration or not? Yes, acceleration bigger than 0. This case cannot. B. A boat moving with uniform velocity. Dang, 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 dang. Uniform velocity. Yes, answer is B. Okay, so actually I hope if you still feel blur, every time when you see the words, translate yourself and write down everything like this. Okay, after some time, your brain will autopilot. Now, next, C, an airplane take off on the runway. Do you think takeoff needs acceleration or not? Yes, acceleration must have acceleration more than 0. Yes, thank you. But our question is we want A0, so this one impossible. A cyclist slowing down means this is called deceleration. Deceleration also count as part of acceleration, means the speed change. Answer B. Congratulations, Bethany. Okay, now number 42. The balance forces that act on the moving object will make the object balance forces. Means net force equals to 0, means acceleration equals to 0, means object at rest, or uniform velocity. I like to use short form like this. Yay, so now no acceleration. Change direction, also changing velocity. So answer is D. Okay. Constant velocity, I would like to use an arrow like this. Constant means never change. My short form. Don't use in exam. My short form. Okay, now which diagram shows unbalanced force? So translate. Unbalanced force means net force is not 0. Means you got acceleration. Acceleration, not 0. Yes. So means you got acceleration. You want the things got acceleration. So a car stops means acceleration 0. We don't want this. A plane take off. Yes, we need acceleration. So answer is B. Yes, thank you, Bethany. Thank you, Josephine. Now, a train moves with constant velocity, means acceleration 0. So don't want. We want this. Submarine stays stationary, acceleration 0. Don't want. Understand? Now, 46, last question. Ali is in stationary state. Translate. A equals to 0. U equals to 0. V equals to 0. When his friend pulled him. So this situation happened because thank you, Bethany. Like no weight difference. Okay, actually when we pull, it's horizontal force. Okay, no need count on the weights. No need count on the weight. So wrong. There's no normal reaction. Impossible. This is the ground. This is the land. Sure got your normal reaction. Sure. See the force here up and down, we don't care. We want the force left and right. So the existence of net force. If there is existence of net force, means there is SA. There is acceleration, but we want acceleration 0. So wrong. So answer is D. Forces in equilibrium means net force equals to 0, acceleration equals to 0. Yeah, thank you, Bethany. Thank you, Sabine. Okay, so now it stops here. Next time we start the lift again. All right. All right. Any other question? You can do your. So actually, you can try to do your module page 32, number 1. The lift, actually this force got many parts. Got lift, got pulley, got balancing. Okay, so well, see this one. Page 35, number 4. Until here. Until here. Now see, actually all of this you can do now again. Now so see the feather you can do just the lift and pulley. I need 2 more classes. One class for lift and a little bit pulley, then next class will be pulley. Okay, not hard actually, not hard. Okay, sorry. A pulley and lift could be one class. The resolution of forces need another class. Yeah. In school, how? Now your time really short. 3 period, not even 1.5 hours. Okay, so no choice. Okay, so now anyone got a question? If no question, we can rest. Okay.